Alright, so I'm just going to demo how this change eye color works. This is for OpenCV Course 2, the first project. So I'm just going to run it real quick and we'll run through what it's doing. So the first thing it's going to do is it's going to locate where the eyes are using the dlib facial landmark detector. And after it does that, we're going to use the hue circle detector to find the circles of where the eyes are. As you can see, it will try and just fit the eye circle, but it's not going to be completely accurate. It will go a little bit over because the circle is not technically complete in the pupil, so you see it go onto the eyelids there, and that does run into some artifact problems later on that I will demonstrate. But the final image looks pretty good, looks pretty realistic, changing just from blue to brown eyes, and yeah, so that's the result. And now I will walk through the code real quick. So the beginning, just our common imports, then we're going to do some matplot settings, just allow us to use matplotlib from the command line, put our font that's not used unless we're in a test mode, and then where the landmarks are. So those are just what the landmark that you saw. I'll run it again real quick just for an example. So these here landmark numbers happen to correlate, so 37, the 38, 40, 41 that you see here. So those are from the dlib landmark. It will just return us a bunch of values, and these happen to correlate there. And then here we're just going to bring in our dlib facial landmark detection. That's just the path, and then grab the face detector, create the shape predictor based off of the landmark metadata that we already have, that we downloaded for dlib. And then this is just to bring in a variable image if I want to run the same code with a separate image instead of blue. You could also run it with brown eyes or green eyes, for example. So that's all that code's doing. Show image, if we want to show the image using OpenCV, that's just a helper function. Get face landmarks, it's going to actually run the facial landmark detection. First, it will find the face in the image, and then after we find the face, we're just going to use, it will actually find all faces in the image, but we really only care about the first face because there's only one face in all of them. And then after we know where the face is at, we will use the shape predictor to find these dots here for the facial landmarks. And so that's all, so that will just return all the landmarks. When we want to draw the landmarks like we see here, just for testing, it's good to see where the landmarks are while you're testing. So I have a helper function here, and if we want to see what the number, where I got these numbers from, these here, we could set this test to true and also put the number there. So this part is going to put the number, and this part will draw the actual green color, as you see. So RGB, we're just going to make the color green, and so you see the green colors there. For the hue transform, that was the second part. So this part, this hue circle, this function is going to, given some parameters, which I basically just played around with. Edge sensitivity threshold is just the how, like, I believe it's like the pixel threshold sensitivity, like how crisp the edges are in the circle that we're looking for. Accumulator is like how many circles did we find based off of the hue detection, and here we need to find at least like 10 overlapping circles for us to count it. Inverse is just the inverse of the edge accumulator, and then min circle distance is going to be how far the circles that it finds can be from each other. And so we're using the eye distance, the distance between the eyes, and then making it a little bit smaller just to have a little bit of buffer there. And then what I'm doing first is converting it to grayscale, so that's why you see this image is gray, makes it less noisy to find circles. And then I will enter in all those arguments. The only ones that we didn't go over are the radiuses. So I actually decrease the min radius by 1/4 of the eye radius and increase the max radius by 1/2. Just also so we have a little bit more buffer and we find more circles. And then we'll just return all the circles that are found from the hue circle detector. And then to draw those, as you see in the picture, we're just going to use this helper function. Given the circles in the image, we'll just draw all of those circles. This is helpful when you want to filter out the circles. So if I were to just run this without filtering the circles, we'd see a bunch of circles all around. Anything that kind of has circular edges, like over here, you'd probably see some circles. And so we need to also filter those out. So after we're done drawing the circles, we will filter them out. And how I end up filtering the circles out is by using the landmarks. So I try and find the circle that is closest to the landmark. So basically I'm just going to use the landmarks that we found from the face and then average out those landmarks, the X and the Y, and then find the circle that has the minimum distance. So that's all this is doing. It's just going to grab all the distances, and then based off those distances we will just grab the one with the minimum distance. So we look for the index with the minimum distance here, and then yep, that's about it. And then we'll have the left circle and the right circle based off of that. So after we have those circles, we kind of now know where the eye is at. So now that we know where the eye is at, we can create a histogram of the colors. So for the blue eye, we'll create a histogram of all of the colors that happen to lie within this circle. So what that will end up looking like is this right here. And so what I do is I'll look for the most dominant like run of colors here. So I'll look for the bins. This is a bin of 180 bins based off the hue values, and I'll look for the run of the most of the highest sum of hue values. So it'll probably start somewhere around here, pick up these really high buckets in the hundreds, and in this case I wrote a generic function to find the largest n consecutive bins, but in this case I found 30 to be a good number, so I'll find the 30 bins that have the greatest sum basically. And that can also get a circular array. So if the greatest sum, sometimes for brown eyes, you'll find that the greatest starts towards the end and overflows into the beginning. So this function takes care of that as well, of getting like the overflow in case you have to concatenate like two separate arrays. This function will take care of grabbing those bins. So that's basically what we're going to do here. So first we have to change this back into gray, and then we need to find where those pixels are that we got from the circle. So to get those, we're just going to force all of the pixels that we found from the circle detector to pixel value of 2. So that's what we're doing there. I'm also increasing the radius by just a bit to make sure we don't miss any of the pixel values for the eye. This is a little bit dangerous for in case there's artifacts with brown eyes, you'll see, because skin color and brown eyes happen to correlate a little bit, but for blue eyes it's not a problem. So basically we will just force all of those pixels down to 2, and then our eye pixels will be wherever the pixels are exactly equal to 2. And then based off of that, then we'll split the channel into the HSV. We first have to convert it to HSV and then we can split it. And then our eye pixel hues will just be wherever those hues happen to intersect with the eye pixels that we grabbed. And then we create the histogram with 180 bins, and then we will just return the histogram, eye pixels, pixel hues, and our split channels to this change hue of histogram. And then we're going to find those largest bins that I was talking about here, and then depending on where we want to shift we'll pick our destination hue. So brown pixels happen to be about 170 to 180, and then also from about 0 to 20. It correlates pretty strongly to red. And then the blue, I found all of these mostly just based off of some analysis on the eyes themselves and where it would be best to shift them. And the blue happens to be from these hue values, and green the following. And then basically we will just take the values that we found for the hue, and we're going to shift all of those pixels into the destination hue that we want. So we'll grab the 30 largest, and then we will basically, if I want to shift this to brown, then we will move basically the pixels that were all here and shift them down to the brown pixels. And that's basically what this is doing here. So for all the iPixel hues, wherever the iPixel hue is equal to the bin that we found, so say 43, then we want to set that now to the destination hue. And then, yeah, this will actually then convert our hue pixels in that split image that we found. And then we'll merge them all back together, and then we'll have to change it back to a BGR image for displaying. And then the change eye color is kind of like the main function. So we'll first get the landmarks, split it into the points, grab the eye radius and distance based off the landmarks, and that will get shown here. And then, yeah, since we're in test mode, we will draw those as we saw, grab the circles, filter out the circles, create the histogram, and then shift that histogram. And then our final output will be as we saw there. So that's about it.